All right. So hello everyone. Welcome to week 2 of this CAD milestones 3D printing class. Today we're going to be mainly going over some more advanced sketching, like sketching techniques, so we can hone in our sketches, make them really nice for both constraints and just like modifiability. So yes. Also, if you haven't already, please fill out the attendance forms. Um, like I said, if we can hit 90% attendance for all 5 weeks, or I guess all 4 weeks, I'll bring food on the last day and we can kind of have like a food party. So currently, we're at like about 80%. I think this excuse thing is not working right now because some people were excused and it didn't register. But we're about 80% right now. So if we can get that 290, so if you like forgot to submit it, please just do it now. Or if your friend is taking the class and they forgot to do it, maybe remind them. But again, excused and unexcused. Wow, I can't talk. Attended and excused absences counts towards that percentage. So as long as this percent is like 90% for all 4 weeks, then I'll bring food. So please do that. Again, we're still waiting on some people to submit, and I think some people are dropping the course. So this number will go up a little bit, but if you haven't already, just submit it because only, 30%, 35% people have submitted, and I think more than 35% of the class is here right now. So yeah, if you could do that, that'd be awesome. But anyways, today, again, we're doing more intermediate design skills. So I talked a little bit about this last week. We did a lot of dimensional constraints, right? But if you're wondering, a constraint is just something like a tool that we use to define our sketch in a certain way. And then we've mostly been defining like lengths and stuff like that. But we can also define things like like different elements to each other. Like we used tangent last week and equal. But there's a bunch of different design constraints that we can use when creating our sketches, right? So here's just a list of a couple of them. We're going to be using a lot of them today just to kind of get a feel for all of them. So a lot of these terms will probably be terms that you're familiar with, mainly like, parallel and perpendicular. But then there's other stuff like concentric and like coincident that you may not be familiar with. But they all kind of make sense once you read the description. So I'm not going to read through all of them because we're just going to use them, and that's probably the easiest way. And a lot of these are self-explanatory. Again, here's some more. The one thing, I think, okay, yeah, the one thing from this slide that I kind of recommend you don't use is the fixed/unfixed constraint. So it's mainly there for like very specific like use cases. Like the one I can think of off the top of my head, like when you make like pulleys and stuff using like involute curves, which is like kind of a more advanced topic, you might have to use the fixed and unfixed constraint, and it's kind of weird. But most of the time, like when you define stuff, you don't want to use this because fixing it will kind of like lock in an arbitrary constraint, right? So if something's like visually in the right spot and you fix it, it might look fine, but like geometrically, it's kind of arbitrary. And when you fix an arbitrary constraint, you could have some problems and it's not like the most like accurate, if that makes sense. Most of the time, you can use a combination of these constraints and the one on the other slide to fully constrain your model. And that's what you should be doing to have like really robust CAD. So keep that in mind. We're going to teach you how to use it today just so you know how to use it. But in general, like you're not going to be using this. And I'll know if you use it because if I open your sketch and it's like green, then I can tell because I think that's the color that a fixed line is. So don't use it, but we'll teach you. Only use it when in the example that we use. But for the most part, it's not something you're going to be using. But yeah, with that being said, we're just going to jump right into it. We have this document here that I sent in the Discord. So if you go under resources, there's this F3D file. All you do, all you have to do is download it, and then we're gonna upload it to Fusion. So yeah. Also, who doesn't have a mouse? I think I still have my mouse that I haven't given away yet. Okay. So once under the assumption that you've downloaded the file already, you just go into your data panel if you haven't opened it already, and then you just hit upload. You find the file. And then just hit upload. I recommend you put it in like your project folder wherever you made it. And then you can open it. So double click it, should open. You'll be greeted with this nice drawing here. Also, if you didn't know, you can click on the faces on this cube and it'll like snap to that face. So in this case, I just clicked on front. It's nice and easy to see. But what we're gonna do is, you can see there's like some text, associated with each little area here. And then we're just gonna, read what this says and then apply the right constraint, right? So these lines already exist in a sketch, so we're not gonna make a new one. We're just gonna edit an old sketch that has already been created for you. So again, to edit things, you can just go into your timeline and find it. In this case, there's like this photo and then a plane and then the sketch. So we're gonna edit this. So you just right click and edit the sketch. I'm gonna hide this. And then we can start applying constraints. So, last week I talked about this just vaguely, but this is all that we're really gonna be working with for this assignment. You can see here under the constraints, all these red symbols, are associated with, some kind of constraint. And then we can use it to apply to, whatever geometry you have. So you can usually either like shift click the two things that you want, or you can click on the tool and then apply it and then click on them. So, for this one, just shift click, holding shift, selecting the two, and then I apply the perpendicular constraint, and then like bam, it's perpendicular. Cool stuff. For this one, all of these three should be parallel to each other. So you just click on two lines with the parallel constraint and then click on another set. I think usually when you click on that, the two lines kind of morph on top of each other, but you can move them away. And you can see, no matter where I move these, they're always going to be parallel, right? So that's kind of what we're looking for. It gets progressively more complex as you go over, or as you continue on. So I'll just kind of let everyone give it a shot. And then if you have a question about one of them, just raise your hand and I can just do it. I think like the third one and then like the last one can be a little bit confusing for some people. But yeah, I'll let you all go through for like 5 to 10 minutes. Yeah. Okay, so the two hard ones, I'll just do them real quick. Um, so again, this one is asking you to fix one of the circles. Um, so there's three circles, you know, 1, 2, and 3. It says dimension circle number 3 to 2. Like if you didn't know, that's like the diameter symbol, and then it's like 2 inches. So you're gonna create a dimensional constraint with the sketch dimension that we did last week. So circle number 3 should be 2. Uh, it says fix circles 1 and 2. There's technically like when you do circles, there's two different things you need to constrain. There's like the center of the circle, but then there's also like the diameter of the circle. So again, this is like bad practice, quote unquote, but I'm just showing you how the tool works. You can lock or you can fix like the center of the circle, but you can also fix like the diameter. So in this case, you want to fix like the outside. So if you click on them, you see they turn green, right? And when they turn green, like, you know, they're fixed. I can't drag them around. So these are fixed now, and then you make circle 3 tangent to both of these. So you apply the tangent constraint to this one and this one, and then you got, or that's how you do that one. But yeah, this is how I can tell if you're using a fixed constraint because this will turn green. So yeah, I'll be able to see that. For this one, the last one on the bottom right, there's technically 2 correct answers. A lot of people just like make all 3 circles concentric to each other because they're technically on the same horizontal plane, but I'd say the recommended solution is to make them like kind of obviously not on the same like point and then horizontal to each other. So there's the horizontal vertical constraint, and I talked a little bit about this last week, how sometimes you have to massage your sketch to make sure Fusion will constrain it properly. So right now, it's not really in the right spot because if I try to apply a horizontal vertical constraint to this one and this one, so I'm going to select this center point and this center point, this will snap to vertical, right? And it's because like wow, it's lagging. It's because like these 2 points are closer to the horizontal or to the vertical plane than it is to the horizontal plane, right? So Fusion will make an assumption there and think that you want to go vertical. But in this case, we don't, right? So to fix that, because these things are unconstrained, you can drag things. So if I drag it this way, it's a little bit more closer to horizontal than before. And if I reapply the constraint, it should make it horizontal. So this applies to like the horizontal vertical constraint, but I think some people were having issues with like the tangent constraint last week because you can technically tangent align to one side of the circle or the other, but depending on the geometry you're looking at or you're looking for, you might need to move the line to make sure it specifies it correctly. So yeah, the last one should just snap. Yeah. But yeah, this is more of like the intended answer, but technically, like, this is technically correct as well. But I digress. I mean, normally, still that's fine. I want to show you the constraint too. Alejandro. Wow, computer design. Okay, does anyone have any questions about this assignment? I'm hoping it's pretty nice and straightforward. Seems like most people got it, which is nice. Nice. Everyone's so quiet today. I don't know why. Okay. Anyways, oops. So the next assignment is just some more sketching stuff. In this case, we want to create this nice gear here. The main thing about this is we're going to be lazy and we're going to make Fusion do a lot of it for us. In that regard, we're going to be using like the mirror and the circular pattern tool. So basically, this is great because one, it's less work for the designer, but two, it's also less work for you when you might want to modify things later, right? So most of the time when you're making a gear, you want all of the teeth to be the same, right? So instead of CADing each tooth individually, what we're going to do is we're going to use some special tools in our toolbox to make it a lot easier, right? Because, you know, less work, but also it makes things a lot easier when you want to adjust things. I guess I said that twice, but yeah. Okay, so new document. We're going to create a sketch like we've been doing most of the time. So in this case, we're going to kind of be replicating this thing down here. So I'm going to start with a circle, but then I'm going to create like half of a tooth profile, and then we're going to copy the rest. So and make a circle again, starting from the origin. Oh, it's using construction lines. Okay. So I have this circle. I'm going to create some lines here. So I'm going to create a vertical line here, and then kind of an angled line there. You can see that these lines are already turning black because they're constrained vertically. So Fusion will sometimes automatically assume things, and in this case, it was right? We want these lines to be vertical. I mean, I guess I don't really need this to be here, but yeah. So we have these. Typically, what I like to do is I kind of like to throw lines and circles out there and then constrain them, kind of like for the game piece that we did last week. So we have this very rough idea of what we're going after, and then I'm going to start applying constraints. Again, some people like to go line by line, but this is just kind of what I do. So I don't know, let's make this one like 100. Let's constrain this, do like, I don't know, 80. For this, I'm gonna create some kind of angle here, maybe like 100 or something. Specify this width here, maybe like 10. Okay, so this looks like pretty good, but you can see that these lines are still blue, right? So there's something here that's unconstrained. Like in this case, this width and height is constrained, and everything looks like it should be constrained, right? But there's something missing. So one of the tricks I like to do when stuff is blue and I'm trying to constrain it is I just start dragging around to see which way the line or arc goes. In this case, I think the line should just drag sideways, right? So you can see here, this is mostly unconstrained, or this is unconstrained because this isn't constrained horizontally, and this line is not vertical. So you can fix that with some geometric constraints. So we want this line to be vertical, so let's constrain that. But, it can still go side to side, right? And it's because, this doesn't have any constraint in relation to like the origin. So what we can do is we can apply another vertical horizontal constraint with like the end of this line to like this point on the center. Or maybe I'll do it here instead. So we can apply it there and there, and then now it's fully constrained, right? So you can kind of see I didn't add any like dimensional constraints. The only thing I added was geometric constraints. And then this sketch looks almost identical to the one before, but obviously the lines are black, and it's because it's fully constrained. So one recommendation I have when you're CADing stuff is sometimes I purposely make the lines not where they're supposed to go, right? Like, so for example, like this line, when I drew it where it was going to be. And as a result, it didn't apply, like Fusion didn't apply all the automatic constraints that I wanted it to have. And because of that, it was unconstrained, even though it looked like correct, right? So sometimes I like it to make, wow, I can't talk. I like it to look imperfect. So when I apply the constraint, I can kind of confirm visually that it's going where I want it to go, right? So maybe I'll just do this again. If I was to do it again, maybe I'd like have this line kind of going out here and then like going out there and there. And obviously this looks a lot more like quote unquote wrong. But then once I start applying the constraints, I can be a little bit more specific. So I can kind of confirm things as I go, right? So this one. Okay. So yeah, I hope that makes sense. Obviously, this is mostly like a personal preference thing, but I found that sometimes drawing them a little bit strange kind of saves time in the long run, or it just saves you the headache of trying to figure out what constraint you're missing. So that applies to sketches, but it'll also apply to assemblies, which I'm going to get into next week. But yeah, does that make sense? Okay, these are like little like tidbits that I've picked up over the years, but hopefully that kind of makes things a little bit easier. So for the next part, you can see, this is only half a tooth. So what we're going to do is we're going to mirror it to duplicate the other half. So to do that, there's this mirror tool up here. So you can select objects. In this case, I want to mirror this line and this line. And then it'll ask you to mirror it across some line, right? In this case, this line here that we've created is the center of the tooth. So we're going to select that. And when we press OK, you can see we have a nice mirrored tooth. And then if I change anything, because it's mirrored, it will modify the other side. right? So this is good. Okay, does that make sense? Okay, cool. The last thing I'm going to do is I'm going to create, or I'm going to convert this to a construction line. Construction lines are pretty nice because Fusion will ignore those lines when you go to extrude it. So it can kind of like deprioritize geometry that you're using to reference other stuff, right? So if I convert this to construction line, you can click on the line and you click construction over here. I think the other way to do it is to like right click the line and then find the normal construction thing or press X, which is the shortcut. So it'll become dashed. So it's a little bit, it makes it easier for you to like determine what is your construction geometry and what's essential. This will be useful in your homework assignment tonight, so just keep that in mind. The other thing is, obviously because Fusion will ignore these construction lines when you're creating extrudes and stuff like that, if you have like a rectangle and one of them is a construction line, you'll see the highlighted blue section will disappear, right? Because a construction line doesn't, close, quote unquote, close your geometry. You might want to keep that in mind, depending on what you're doing. Yeah. Anyways, we have this nice tooth here. But now we want to duplicate it around a circle, right? So we already mirrored it. We have this nice profile, but we want more of them, right? So I'm going to highlight them. And then down here is a create circular pattern. So we've selected the objects already. You select a center point, which in this case is the center of the circle, and then the quantity. So number of teeth, maybe let's do like 10. This looks nice. And then you just press OK, right? So again, we're being lazy. We only designed one tooth, but now, if I make any change to the original one, all of them get copied. It's super nice. Does anyone want me to do this again? Feel free to raise your hand. Okay. Great. So we have this tooth here. I'm going to highlight it. Also, this is a really random thing, but depending on the direction you highlight, it will select things differently. So if I highlight in this direction, this box is yellow, but if I highlight in the other direction, the box is orange. So when it's yellow, it'll select everything that touches it, even if it's not fully inside. So in this case, you can see I'm kind of skimming across the top, and I've only have parts of these lines in this yellow box, but when I let go, it selects all of it. If I highlight in the other direction, these, kind of diagonal lines aren't fully encased in this box that I've made. So when I let go, it only selects, the portions that were fully inside, which in this case is these two horizontal lines. So that's just a little fun fact about highlighting stuff. This applies in a lot of other CAD programs if you're interested. But anyways, if you create a circular pattern with the parts you highlighted, or you can, click on the tool first and then click on the lines. You can create, or you specify the center point, which is the center of the circle, and then you can modify the quantity. So, also, if you ever wanted to change stuff, sometimes you can see these like little icons highlighted everywhere or just floating around everywhere. These are all the constraints that have been applied, right? So all of these here are like the mirror constraints because these parts are all mirrored. But if you look at the center, there's this icon here. So if you click on it, you can edit, in this case, the circular pattern. So if I wanted to change it, maybe not that many. You can do that as well. that's useful when you want to edit this. But it's also useful if you add something that you didn't want. So sometimes, in this case, you could be like, oh, I accidentally made this line horizontal. This is the horizontal one right here. So there's like, oh, I made this horizontal. I don't want that. You can click on this little icon and delete it. Sometimes they're easy to find and sometimes they're not. So if they are easy, you can just delete them and reapply the constraint you're looking for. But more often than not, I find myself just deleting the line and restarting and making a new one. It might be easier that way. Just kind of depends if you can find the constraint easily. But yeah, that's a little tidbit if that is helpful. Okay, so the last thing I'm going to do here is I'm going to trim away the rest of these lines. You can also just extrude it and select these bodies individually, but I'm going to trim away. So I'm going to use the trim tool. I'm going to cut away all these lines that I didn't want. Okay. Oh, and I cut this away on accident. Great. Oh, oops. Okay. So that's a good example of when Fusion doesn't do it the way you want it, because it was easier for Fusion to go this way to make this arc equal to that instead of going the other way, right? So if I reduce this, come on, you can do it. If I reduce it to be like that and I reapply the constraint, it should be correct. Okay, there we go. All right. So now that this is a nice closed body here, I'm going to extrude it just like before. And then bam, we have a nice gear looking piece. Does that make sense? Is there anything that I should do again? No? Feel free to just like yell at me if I'm going, if I did something that you didn't know how to do. Okay, so for the last one, or the last part of this assignment, we want this threaded hole here. So I'm going to go on a little spiel about why we use this tool. But in this case, it's kind of relevant because we have a threaded hole, but sometimes you just have a hole that you're drilling and it's just a straight hole, right? So let's say, that hole might be like, 1 inch in diameter. You could just like make a sketch, make a circle, and then extrude it. And while geometrically that might be like correct or what you're going after, you do lose some information when you do like an extrude in that way instead of drilling a hole. So in Fusion and in a lot of other CAD programs, they have some kind of hole tool or hole wizard. So, the Fusion tool is here, right? And this is useful for manufacturing because sometimes you'll send someone your design and they're going to try to figure out how to make it, right? If you send someone like a drawing where all the holes are extrudes, then the CNC program that will convert your model into a toolpath might assume that a drilled hole is a pocket. So if you know anything about like manufacturing and stuff like that, a pocket, isn't necessarily just a circle, right? It could be like a triangular shaped hole, and then they have to use an end mill to drill out the hole, right? And using an end mill versus a drill bit is a little bit different. These are kind of minute manufacturing differences, but you lose a lot of that information when you create an extrude instead of a hole. And this is also the case when you make part drawings. So Fusion has like a part drawing tool where you can create, your model and then print it out on a piece of paper with all the critical dimensions. And when you just use an extruded hole, you lose some of that because when you have a hole call out on a part drawing, you can be like, oh, this hole uses like this kind of drill bit, it goes this deep, and maybe you have multiple holes. So you could be like, oh, I want this to be done like 3 or 4 times, right? An extruded hole or an extruded sketch isn't going to give you that information, but the hole tool will. In this case, like I really recommend you use the hole tool. Also, you lose points if you don't do it. But in this case, there's a threaded hole, right? Obviously, if you wanted to model a threaded hole manually, you're gonna have to like create a sketch with like a 3D spiral going down the part, and then the profile of the exact like thread of the screw that you want to put in. And that's obviously a lot of work. So, the hole tool in this case is going to save you a lot of time, but it also retains a lot of information for people who might be manufacturing your part. So in this case, I would recommend the hole tool, but sometimes when I'm just like CADing for something by myself, I'm like lazy and then I only do extruded cuts, but it's technically bad practice. So I wouldn't recommend you do that if you're designing a part to be manufactured. So yeah, this will make a little bit more sense once I use the tool. So I clicked on the hole tool. I'm going to select a point. And then you can see here, there's a lot of different like parameters I can set, right? There's like a straight hole, like counter bore, countersunk. Those are mostly for, holes that aren't tapped. But then, you can add like threads by tapping it or even have like a tapered tap. All of this would be really annoying to model manually. So this hole tool is really nice. So in our case, we want a threaded hole. So I'm just going to do tapped. And then here, you see this depth is specified along with a bunch of other stuff. In this case, like the thread type, it says it's an M70 by 6. But yeah, there's a lot of critical information here that you may lose when you just use a normal extrude. So in this case, I want it to go through the whole thing, so I just set it to all. And then I can specify some kind of size here. But yeah, once I create it, we have this nice threaded hole. And you can see here in the timeline, it'll tell you that you use the hole tool. This is why on the rubric it says to take a screenshot of your timeline so I know that you use this. That's mainly why that rule is there. So please, when you submit this, don't just take a screenshot of the gear. Please show your timeline. I don't want you to lose points for no reason. So yeah. Does that make sense? I know I've been like rambling a lot, but I hope all of this information is useful to you all. Yeah. Sweet. Okay. We're like really ahead of schedule. We might leave early today. Okay. Does anyone want me to go over this, like any part of this assignment? Are we all good? Okay. You guys are really fast. Normally I have to go a little bit slower. But... Okay. Assignment 6, the hairdryer assignment. So you kind of already know how to create, more advanced sketches. But in this case, we're going to be creating some more simple sketches, but we're going to be specifying them in different places. So typically, when we've been creating sketches, we've been starting off on the planes that Fusion gives us, but we can also create our own planes to make more advanced geometry. So in this case, we want to make this hair dryer. Obviously, we could just like draw some profile and revolve it, but there's other ways of doing it, right? So today I'm going to do it with a loft. Obviously, the revolve tool works, but we want to teach you all the tools we can. So yeah, please use a loft today. So you can see here how this works is we're going to draw multiple different profiles on different planes. and then we're going to kind of combine them into one solid model. So we have these 4 circles here. They're going to be on 4 different planes, and then we're going to loft it. So new design. Instead of creating a sketch like we have been doing before, I'm going to go over here. There's this construct tool, and then I'm going to create some planes. So I'm going to start with an offset plane, and I'm also going to use the mid plane just so you can see how they all work. So here, offset plane. These are all 3 planes that Fusion gives us from the start. I'm going to go vertically, so I'm going to choose this plane here, the top plane, to offset from. You specify some distance, I don't know, like 20. Also, I'm going to show all the other ones here. So if I unhide all the origin and all the planes, you can see here, this bottom plane is the top plane. This is the one we just made, and then there's 2 there. I'm going to create 2 more planes. So I'm going to create another offset plane. I'm going to make this one quite a bit larger. I'll do like 100. And then for the last one, I'm just going to use a mid plane just to see what happens. For mid plane, you select 2 planes, and then it just puts one in the middle, hence mid plane. So yeah, we have added 3 nice planes here. And now we're going to add some sketches onto them. So you see here, there's 4 circles, and they're not all on the same plane. They're all on separate planes, the ones that we just created. So I'm going to create a sketch, draw a circle. I highly recommend you base them all from the origin. I'm going to draw another one in the plane above it. And then one more. And then one last circle. Okay, so you should have something that looks like this. Okay, raise your hand if you need more time. All right, sweet. couple years here now. Now we're going to create the loft. So over here, you go create loft, right here, and then we start selecting profiles. When you create a loft, you want to make sure the profiles you select are in the right order, because if you don't, then they're going to kind of make the loft like go inverted and inside out. So here, I'm going to do it wrong first. So, let's say I click on this one and I skip this one, and I click this profile here. Please select. There we go. And then like I specify this one. You can see how like the loft like inverts itself, and that's not really ideal. It's not really what we're going after. So you want to make sure you select it in the order at which you want the loft to be created, right? So you can see here, it'll create a really nice smooth profile going from one circle to the other. When I press OK, I have this vase looking piece. Cool. Yeah. Does anyone want me to do the loft again? Okay. So create loft right here. You just click on the different profiles going up, and then you just press OK. Yeah. Okay. So the next step here is we're going to hollow out the inside of this hair dryer, and then we're going to apply a fillet. I'm purposely going to do the fillet incorrectly just so you guys see something later, but I'll tell you what to do correctly if you want to do it right the first time. But we're going to hollow it out using the shell tool. The shell tool is really nice because it'll create a constant width throughout, your hollowing out, if that makes sense. Like this is a very complex curve, right? So to create like a shell, it will hollow out like exactly the amount and keep the wall thickness the same all the way down. So this is nice for this. But if it was like a straight extrusion, you could just do, some kind of extrude and it might be a little bit easier. But the shell is pretty awesome. So in this case, I'm just going to use the shell tool and I'm going to click the top face. And when I click on it, it's going to hollow out everything to the desired width. So if I change this thickness to like, I don't know, 10, maybe less, like 4, you can see the thickness on the inside is constant throughout. One thing that's cool is you can select like other sides. So like if I select this bottom face and the top face, or not, it's getting mad at me. I'll just do the top face. But it'll create a constant width throughout, right? So this is nice if you like want to design like a vase or something, you can apply the shell tool. Like some 3D printed vases have really awesome like geometric patterns on the outside. And if you were to model that or try to extrude it or cut it out manually, it would take a really long time. But the shell tool would just make sure that everything is nice and consistent. Let me see if I can find an example. Yeah, like something like this. Like if you modeled this and then you tried to create like a constant cutout for the walls, it'd be really hard to do that with extrudes and stuff like that. But if you just use the shell tool, you just click on the top face and then it's really nice. It's like perfect all the way around. So that's like a good example for when you might want to use the shell tool. Anyways, once I've created that shell, I'm going to create a fillet. Again, this fillet is going to be like quote unquote incorrect on purpose. So you should just fillet the outer edge of this, but I'm going to fillet both of them so you can see what happens when you create dependencies. So keep that in mind. You should just be filleting the outside, but I'm going to be doing the inside and outside. I'm going to create a fillet 1 millimeter there. So the model should just have a fillet on the outside. Don't do the inside. Or you can do the inside and follow along. Anyways, once we have that, the next thing we want to do is create this handle here. So what I'm going to do is I'm going to create an offset plane that kind of extends past this body, and then I'm going to do a two-sided extrusion. So I'm going to create construction line. I'm going to reference this plane right here. I mean an offset plane, not construction line. And then I'm going to make the plane stick out beyond the body. So maybe like -70 should be good. So again, this plane is beyond the hairdryer head. Okay. I'm going to create a sketch on that plane we just created, making a circle for the handle. Okay, this is a good example of when sometimes I create the geometry in the wrong spot and I specify later. Because sometimes when you create lines and stuff like that, it might snap to like this green line here, but it won't actually constrain it. So I like drawing my lines kind of offset from where they want to be before I constrain it, or not lines, circles. So I'm going to draw that circle, kind of add a diameter, add a height here. And then you can see I'm going to, for the last constraint, I'm going to move it a little bit closer. And I'm going to apply horizontal vertical constraint, right? It's nice and fully defined. So I'm going to do it underneath here while snapping to this green line. You can see here, I apply the same dimensional constraints, obviously different numbers. But you can see here, like positionally, it's on this line, but it's not actually constrained, right? So that's why I drew it away, because sometimes this isn't obvious. And when you create more complex sketches, you'll be like scratching your head and you'll be like, why is it constrained? It's in the right spot. So yeah. Anyways, we have this circle, maybe make it a bit smaller. And then I'm going to extrude it. So I'm going to select this body. And then for the direction, instead of one side, I'm going to do two sides because I want it to extrude this way and then also the other way. So two-sided extrusion. For side one, it's highlighted in blue, and I think the side two is in gray. The extent type for side one should be to object, right? And what this will do is, this face right here on the hair dryer is not a flat face, right? So if I added some kind of like numerical like constraint and I had it as a join, it would kind of cut into the model like this, and that's not really what we're after. We want the extrude to go exactly to the face. So if we have it as to object and we click on this face, it'll extrude it perfectly like up to that surface without any stick out. So that's pretty nice. For the other direction, I'm going to specify this distance to be, some arbitrary number, be like 120 or something. So you can see here, one side, it's nice up to the surface, and then this side extends all the way to some number that we're going after. Who wants me to explain that again? Okay, no problem. So again, I'm going to create an extrude here that's two-sided. The first direction, we want it to go up to the surface. So we set the extent type to object, and then when we click on it, it extrudes up to the surface, right? The extrude is, curves around this. It's super nice. And then the other distance is just some other number that we want. Yeah. We also want to chamfer the other end. So I go under modify, and under fillet, there's a chamfer tool. Click on this edge here, specify some number, and boom, we have this here. Does anyone need more time? Oh, wait. So now I'm going to talk a little bit about dependencies. So if you did like the fillet on only the outer edge, you should be able to do this. But if you did it incorrectly like I did, you shouldn't be able to do this. So basically, the cool thing about Fusion and a lot of other CAD programs is you can move the features that you've created like in your timeline around, and it can result in different, like slightly different models, right? So in this case, I have these planes here, I made these sketches, I have this loft, and then all these other features, but we can purposely reorder them to get a different result. So in this case, like I created this shell right after the loft and it hollowed out this area. But let's say, for example, I want this section of the extrusion to be hollow as well. So I can fit like electronics in there or something, right? I could create another shell, or I can move this shell to happen after all of this stuff I've created, right? So right now, if I try to drag this, you can see I can like, there's this little line there. If I try to drag it forward, it doesn't let me, right? And the reason why is because I created a dependency with another feature, right? So if we go back in the timeline, right here is right when I created the shell. Right after that, I created a fillet, right? And because I filleted the outside and the inside, this fillet is dependent on the shell, right? Because it's mainly because of the inside one. If this shell didn't exist, then I wouldn't be able to fillet the inside because there's nothing to fillet to, right? So I can't move this in front of this fillet because this fillet needs to happen like after this is created, if that makes sense. So to fix that, I need to remove the dependency. So in this case, the dependency is this edge here. So if I reselect and I just select the outer edge, this fillet is no longer dependent on this shell I've created, right? Because regardless if this shell existed or not, this outer edge was there already. So if I move the timeline forward to where I have this handle and I try to drag the shell, you can see that the bar now moves along with my mouse, right? So when I let go of it, it'll recompute. And if we look inside, we can see the inside is now hollowed out, right? So that's kind of what we're after. This is kind of a important concept to remember because sometimes you'll be making something and you need to move something and it doesn't move and you need to figure out why. So in this case, like I purposely did it wrong so I knew what was wrong. But sometimes you have to do some problem solving to figure out where the dependency is. The other way you could have done this is you probably could have moved this fillet forward and then moved the loft forward. So, you know, because this fillet is dependent on the loft, I can move it forward now, and then I can move the shell forward to be right before the fillet, and then I get the same geometry with that fillet that we retained, if that makes sense. That makes sense? Cool. All right. Okay. So for the last part of this, we're just creating this nice wire. And to do this, we're going to be using the sweep tool. It's kind of similar to the loft where we're creating multiple sketches and then projecting some kind of feature onto it. So in this case, we have this path here, which is just one simple curved line. And then we have this circle, right? So we can make this curved line follow this profile, or this profile follow the curved line. I can show you an example of where this might be useful in a little bit. So I'm going to create two sketches. I'm going to start with that wire. So in this case, I want the wire to be centered on this circle here. But sometimes it's kind of hard to find it. In this case, it kind of snaps to where I want it. Sometimes it doesn't. So if you want to reference other geometry from stuff that you've created, you can project the line or project like the geometry. So, if we look at this here, this is a circle, obviously, but from this perspective on the right plane, this is just a line. So if I project the line, or if I project the circle, I can create a line that I can reference off of. So I'm going to press P, which is the project shortcut, and then I'm going to click on this edge of the circle here, and then I'm going to press OK. You can see it kind of created some stuff here. I'm going to hide the body so it's a little more obvious. A projected line is purple. So if you're ever wondering what this line is, it's because it's projected. In this case, I'm drawing a wire off of it. So I'm going to use the midpoint of this projected line to start from the center of the circle and then go out. So I'm going to create a line. I'm going to find the midpoint, which is this triangle right here, or the triangle like icon. If I don't, I can make it midpoint later. So I could make this, obviously it's not in the middle. I can apply the midpoint constraint, so I can click on this line and then this point, and it becomes the midpoint. I want the start of the wire to come out straight, so I'm gonna make this horizontal, and then I'm gonna start sketching my wire. So for this, I want it to look a little organic, so I'm gonna be using this fit point spline tool. I'm gonna start from here, and I'm just gonna click my way down, and then it'll make a nice curvy wire line here. And then when I'm done, I just hit the check mark, and then it creates this. These like green lines here are not actually the spline, but you can kind of drag them around to manipulate how the spline acts if you're curious. I'm just going to kind of leave it, but I will make the spline tangent to this line so it's nice and smooth. So tangent between these two, and we have a nice smooth transition there. I'm just going to leave this unconstrained just because it's a spline. So we like that. The last thing we're going to do, or the next thing, is just create that circular profile. So I'm going to create a sketch on the face of this handle. And I think I'm drawing onto my previous sketch, so it kind of constrained itself automatically. Nice. Okay, who needs more time? Okay, I'll wait like a little bit. So to create the sweep here, we're gonna go, oh wait, I'm in the sketch. I'm gonna go create sweep, which is right above the loft. We're gonna select the profile, which is that circle we created before, and then the path. So in this case, the path is right here. So the circle will be extruded along that line that we created. So it should look like this. Does that make sense? Raise your hand if you want me to do the sweep again. Okay. So there's a sweep. The profile is the circle we created. And then the path is that line and spline combination we have. And then we press OK. That should be it for this assignment. I guess I can show you like a good real world example of when something like this might be nice. Let me see if I can open it. This is a partially an advertisement for the toy design class if you want to take it. It's pretty fun. But for our midterm project, we had to make a battle bot. So I, designed the chassis. So here we have the chassis of our BattleBot, and we needed a channel to run the wires, right? So there's some motors that go inside, like these channels here, but we wanted something like a path for the wires to go through because we had electronics in the back that we're connecting stuff to. So to do that, I created a couple sweeps here. So let me see if I can find it in the timeline. Yeah, so if I click on this, you can see here, like I made one sweep here and then another sweep here. So it's a nice smooth path with two sketches. So I created this sketch here, which is the path, right? And then the profile, it doesn't have to be a circle, right? So in this case, the profile was kind of like this rectangle with like a teardrop shape on top. So you can do like other weird geometries and stuff like that with sweeps. So that's a nice example of one right here. So yeah, it's not used for just like random wires and stuff. You can make it pretty precise to do exactly what you want. But yeah, that should be it for this assignment. Yeah. Okay. So basically, that's basically it for today. Your homework is to create an extrusion profile. So basically, this is an extrusion profile of an aluminum extrusion. These are typically used, or these are pretty common like building materials when people make frames and stuff like that. I guess if you're here for week 5, I'm going to bring my 3D printer into class, and it's made of extrusions that look like this. So it's really useful because these channels can be used to insert like nuts and bolts and stuff like that. So you can screw things to it. So a lot of people make like workbenches out of this stuff, and then they can mount like accessories and whatnot to it. So extrusions are a pretty common thing that people like to use. But modeling them, can be a little bit tedious, but it is your homework assignment for this week. You can see here there's a lot of there's a lot of different features in this sketch to create the aluminum extrusion. And the goal for you is to model this profile using these measurements given um, so that they're exactly the same. So, in almost all the other assignments, I don't ask you to copy the dimensions, but for this assignment, your sketch should be exactly the same. So this is what it should look like when it's finished. I will say that this photo in the slides is missing a couple dimensions. So because of that, I've included another photo on the next slide. And this also gives you a sneak peek of what you should be going after. So this is modeled in another software, so you shouldn't be able to copy this, but this is all the same. So using the geometric constraints that you learned today, you shouldn't have to add any more dimensions than this, right? So like, for example, like this is like part of the extrusion profile. A little hint for you is I drew like a construction rectangle, a construction square, right? So like this top line doesn't have any dimensional constraint because it's geometrically constrained to the vertical one, right? So these two should be equal. You can see here, like, I don't know how useful some of these are, but these little icons here are like icons of the constraints applied. So you can see like this line is like horizontal and equal, and it's equal to this one. But yeah, you shouldn't have to add any more numbers. So if you're adding like another zero point 0.9 or like another zero point 0.8, you would get points deducted. So please don't do that. I will say, in my opinion, this is probably the most challenging assignment of this class, including the final. I think the final is a little bit easier than this. But like if you can model this well and have it fully defined, then you'll be well on your way to create like really nice sketches, right? So this is supposed to be a challenge for you, but at the end of the day, you can become, a better designer after this. So yeah, if anyone has any questions about this assignment, feel free to reach out. I think this is the assignment I get the most questions about. So please just ask if you're confused about something, because I'm more than happy to help you. Because I want you to be good at this. So please ask. But yeah, that's basically all I have for you today. I'll see you all next week. Please fill out your assignments and forms and stuff like that. But I'll be here for a little bit if you have any questions. Oh, yeah, another hint about this, you can see here, similar to like the gear assignment that I did, um, I modeled like half of a quarter of the extrusion. Then after this, I mirrored this, and then I circular patterned all of it, right? So that's probably something you might want to consider instead of having to create all the geometry yourself. You can have Fusion do the most of it for you. Um, but yeah, also, when you submit this, please submit the sketch open so I can see all the dimensions and the constraints you have. Some people have submitted like them finishing the sketch and then extruding it, and I just have a profile, but I'm grading your sketch. So don't submit the extrusion because you don't need to extrude this. I just want the sketch. So it should look like this, but complete, if that makes sense. But yeah, I will see you all next week or right now if you're gonna stay here.
Thank you.
Mhm.